As you know that we will only have 2 weeks left, and probably there will be only 6 or 7 lectures left for the whole term. And our final exam is scheduled a little bit early. The time is scheduled. Let me quickly check that one. It's scheduled on. If I remember correctly, it's on December 13th. That'll be the Monday, Monday afternoon from 4 to 6:30 p.m. And it's quite close. It's very early in the final week. So I would like to reserve some time for you to go through to review the final exam and also to give you some review sessions. So approximately all the contents will be finished by the end of the next week. And then for the rest of the week, we will go through the review, and probably on December 8th, we will not have any class. I'll reserve the time for the office hour so that if you have any questions, you can come by to drop in the office hour meeting to get the answers. I'll give you more descriptions about those issues, the arrangement on Avenue to Learn later. So that's it. And also I have just uploaded the homework 4. You can start working on homework 4. Also I will try to post the solutions about the homework 3, and you can start the preparation of the for the end of the class and try to get an early preparation for the final exam. Okay, if you don't have any questions, I would like to start lecture today. And if you have, just feel free to leave your message in your questions in the meeting chat or raise your hand. I will try to pause it and answer your question. Okay. Okay. With that, I will start lecture today. So in the last lecture, we have introduced, give you some basic ideas about the AI method. We will go through the introductions about some fundamental variables we need to use for the AI method, including the estimations of the ESAAL, and also the design criteria, which will include the fatigue cracking and permanent deformation. Both of them will be applied for us to select the thickness or estimate the thickness for the pavement layers. Regarding to the estimation of the ESAL, we have different models to estimate the load equivalency factor. And if you have the ESAL, you have different values about the tile pressures, you probably need to do some corrections or some adjustments to make sure that they will be it will fit to the standard ESAL values. That's what we introduced in the last lecture. The next thing we have to consider for the AI method is the properties of the subgrade layers. We will especially want to understand the impact of the resilient modulus of the subgrade to the performance or to the design of the flexible pavement. So usually we will consider the resilient modulus of the soil or the subgrade soil within 600 millimeters in the design area, and this is just some typical values we're going to use, and it's from the empirical analysis. And the resilient modulus is usually defined as the value under certain percentiles. The typical values would be 60%, 75%, and 87.5%. And we're going to need to use the different percentiles depending on the traffic conditions we have to consider. Usually to get the resilient modulus, as you know that in reality, the resilient modulus for the soil, it's by subgrade soil. It's not a constant. It's actually changing at different locations at different materials in the pavement. So what we do is like we want to do the test for multiple times. Usually it will be 6 to 8 tests for each section, and then we will have the value 6 to 8 values about the resilient modulus, and with that we're going to have the distributions about the resilient modulus. Also, if you don't conduct the MR test, instead you do the CBR test, you can use the empirical relationship between the MR and the CBR to estimate the MR values. So this is what we introduced in the previous lectures about the soil properties. And now I'll give you some hint about how to do the how to find out the values of the resilient modulus for the design of the flexible pavement with the AI method. First of all, we have to find out what kind of percentage we need to use. Usually, depending on the traffic levels, if the ESAR is below than 10,000, we will consider 60 percentiles. And if it's between 10,000 and 1 million, so this is a very large range, we're going to use the 75 percentile. And if it's higher than 1 million, we will have to choose 87.5 percentile. And the figure below shows the distributions of the resilient modulus and their different values. And you can actually see that with a higher percentile, usually with a higher percentile, which would be the vertical axis, the higher percentage. The resilient modulus will be smaller, which means that if you have the higher ESAL, you will assume that the resilient modulus of the subgrade would be smaller, and in that sense you need to design larger thickness for the pavement layers. So that's the basic idea. And for this specific example, you can find out the 87.5 percentile as with the value around 53 megapascal. For 75 percentile, that will be around 60 megapascal, and for the 60 percentile is 67 megapascal. So that's from one distribution. And now I'm give as I mentioned previously, if you haven't done the MR test, you can actually conduct the CBR test to find out the CBR values of all the subgrade soils. Do multiple tests. This is what we can do in the field based on the CBR test and the liquid limit test and Edinburgh limit test and so on. So usually for the base, we will have the CBR around 80%, for the subgrade around 20%, the subbase around 20%. So those will be some typical values. And then what we will do is like we will want to use all this information to design the thickness of the pavement layer based on the AI methods. And for the thickness design, we will need to think about 3 parameters. The first one is the mean annual air temperature. This one is applied to determine the whether there's any first and soil effect to the pavement. And the second one is the resilient modulus. As what I explained previously, you need to determine the distribution of the resilient modulus in the pavement, in the side of the pavement, and then find out the correct percentage. And the third one is the ESAR, which would be the traffic load. And so that would be the 3 major variables you need to think about for the thickness design. Once you have determined these values, you can then go to select the chart. There will be some empirical chart from the AI method to determine the thickness of the pavement structures. So those charts will only help you to identify the minimum asphalt concrete thickness. Usually that will be around 2 to 5 inches, depending on the structures of the flexible pavement and also the properties of the subgrade and the traffic load. And it's also able to determine the emulsified asphalt base thickness by subtracting the minimum asphalt concrete thickness from the total asphalt concrete thickness. So usually what you would observe is like for the flexible pavement, you will have with the AI method, you're gonna just see. So you will have the base layer. Base layer is the it's some particles or some crushed stones that are going to apply about the subgrade. And the AI method, those charts provided by the AI method will only help you determine the thickness. The thickness of the asphalt surface layer and the emulsified asphalt concrete layer. So as the AI method will only tell you the total thickness of these two layers. Layer 1 and layer 2, both of them are the asphalt layer. You also need to determine the emulsified asphalt concrete layer. To do that, you will need to use the total thickness from the AI method minus the minimum thickness of the asphalt surface layer. So that's what you do to find out the thickness of all these two layers. And also there will be some instructions from the AI method to tell you what's the thickness of the base layer you have to select. So that's the overall idea from the AI method. And for now, I will just give you some more information about these three variables that we're going to use in the AI method. The first one is the mean annual air temperature, MAAT. So it depends on the values. We will categorize the situation into three freeze first effect. If the mean annual air temperature is less than 7 degrees, then we see that there are some freeze first effects. If it's between 7 and 24 degrees, we see that there are some possible freeze first effect. If it's higher than 24 degrees, it means that there's no freeze and frost effect. So those would be three different categories you need to specify. And then based on the freeze frost effect conditions, we will need to choose the right chart from the AI method to determine the thickness. So that's the first variable, the mean annual air temperature. And now let's see how we can find out the thickness from the AI method. So if we say that for the case with the freeze frost effect, which means that the MAAT is less than or equal to 7 degrees. In that sense, we have three situations. The first one is about the this one is applied for the deep strength pavement. If you can still recall the deep strength pavement, you can see that it will include 3 layers. So the first one is the asphalt surface layer. The second one is the asphalt base layer. And the third one is the granule subbase layer, granule base layer. And then it has the subgrade, all placed on the subgrade. So the thickness from this chart will tell you what's the value of what's the total thickness of the both asphalt layers. So what are you going to do? You're going to try to identify what's the percentage, or what's the percentile of the MR. Say that the MR value you defined it's say it's 100. If I say it's 100, if just one example, if say that it's 100 megapascal, and if we say that the ESAR is 1 million, so this is say that this is 1 million, then you can try to identify the thickness by finding out the intersection of these 2 points. So in these 2 points, you can find out this point. Based on these 2 lines, you can find out this point would be the point with the MR value of 100 megapascal and the ESA of 1 million. And it's actually between 2 lines. One line is 125 millimeters. The other one is 150 millimeters. So you can then use some linear interpolation to find out what's the value in this point. So based on that, say that the value here probably around 140 millimeters. So this 140 will be the total thickness of the both asphalt layers, and that's for the deep strength pavement, and is actually applied. This chart is only applied for the deep strength pavement with the thickness of the subgranule base of 150 millimeters. So for the granular base, the thickness is 150 millimeters. So this is the first chart. We also have another situation. The AI method provided another chart, which will be applied for the granule base. The thickness of the granule base around 300 millimeters, and this chart is also applied for the situation with the freeze and frost effect. So the temperature MAT is less than 7 degrees. And if we take the same example, like the MR is 100 and the ESAR is 1 million, you will find out the value you get. The value you get is probably only around 130 millimeters. It's smaller. This is reasonable because you have the thickness of the granule base is larger, which means that you have a stronger support from the lower layers, and in that sense, for the support of the asphalt layers, you don't need to have very large thickness. Again, I should mention that for all these values, for all the thickness you calculate here, those would be the minimum thickness. In your design, you can make it larger depending on the specific requirement from the project. So that's for the deep strength. This one is also for the deep strength. we also know that there's another type of the structure, flexible pavement structure, which is called the full depth structure. In the full depth structure, we will not have any granular base layer. Instead, we only have two layers: the asphalt surface layer and the emulsified asphalt base layer. So these two are placed directly on top of the subgrade, and this is called the deep depth flexible pavement. And similarly, for this type of the structure, you will also have a chart. The AI method also provides a chart for you to determine the thickness of the both asphalt layers. So say that let's just take an example, the same example with the ESA of 1 million and the MR of 100. Then you can find out the total thickness of the both asphalt layers will be around 175 millimeters, which is larger than the two deep strength pavement. So that's for the design of the flexible pavement with the average annual air temperature around less than 7 degrees. So we will have the chart for the deep strength pavement with the thickness of 150 millimeters for the granular base, and we have another chart for the thickness of the granular base around 300 millimeters. We have the chart for the full depth flexible pavement, and we also have the three charts for the situation with the possible freeze frost effect. So that will be the MAT around 15.5 degree, indicates that the temperature is between 7 and 24 degree. So it's the same thing. This chart shows the thickness design for the deep strength with the granular base of 100 millimeters. And this chart shows the deep strength with the granular base around 300 millimeters with a possible freeze frost effect. And we also have the charts to show the thickness with the full depth flexible pavement. So that's for the second case with possible freeze frost effect. And for the third situation without any freeze frost effect, which means that the temperature is higher than 24 degrees, we also have three charts. The first one is for the deep strength pavement with the granular base of 150 millimeters. Similarly, you can use the MR values and the ESA to find out the thickness of the pavement, the asphalt layers. The second one shows the deep strength structure with the 300 millimeter granular base, and the last one shows the full depth asphalt pavement with the without any freeze frost effect. So those would be the 9 critical figures for you to use with the design of the AI method. And also there will be some typical recommendations from the thickness design in the AI method. So first thing is like we will always place a minimum of 150 millimeters base course, the granular base course, over the low quality subbase. So especially when the subgrade is the quality of the subgrade is very worse, then you should place 150 millimeter granule base layer there. You can also use the 300 millimeter base course to minimize the frost action. If there's a severe frost action, you should apply 300 millimeter granule base. And another thing is like for the design, it's not recommending you to reduce the asphalt concrete thickness by increasing the thickness of the granule base. This is not recommended. Because the asphalt layer also has different functions. For example, for the to resist the crackings, to resist the larger load. The increasing the granule base layer, the thickness of the granule base layer, and reducing the asphalt concrete thickness is not a recommended solution for the pavement design. So that's some recommendations from the AI method, and also we have some minimum thickness recommendations for the asphalt wearing course, which would be the asphalt surface layer. Usually for the parking lot or the driveway or the rural road with the ESAR less than 10,000, the minimum thickness for the asphalt surface layer should be around 25 millimeters. If there's a road with median truck traffic between 10,000 to 1 million, then the minimum thickness should be 40 millimeters. If it's a very busy road with a lot of truck traffic, the ESAR is higher than 1 million, then the minimum thickness should be around 50 millimeters. So that would be some typical recommendations for the full depth asphalt pavement. While for the deep strength, we have some different recommendations. The minimum thickness for the asphalt concrete layer. So this would be the asphalt layer surface plus the asphalt emulsified asphalt base layer. So that would be the summation of these two. For the ESAR less than 10,000, the minimum should be 75. And you have to combine this one with the one you obtained from the figure. If for both conditions, both minimum conditions should be satisfied. If from the figure, from the chart, you get the minimum value is around 50, then you still need to choose the minimum value as 75, because this will be some recommended value for the deep strength as for the pavement with some empirical data. And if it's in the medium traffic, the minimum value should be 100. If it's in the heavy traffic, should be around 125. And also there will be some simplified AI design approaches. And this is actually only applied for some parking lot, some driveways and unloading area where you don't have any, don't have a lot of analysis about the traffic, the frequency of the flows. Usually for this kind of roads, for this kind of pavements, you need to think about the number of the trucks will be there, will parked there, and that will be the those roads, and also the quality of the subgrade soils, excellent quality, excellent good quality, fair quality, or poor quality. For example, if we consider the parking lot with a 200 to 500 stored truck every day, then with the fair soil, subgrade soil quality, then the thickness for the minimum thickness for the full depth as for pavement should be around 100 millimeters. And if it's for the deep strength, for this part, that will be the deep strength. For deep strength, you will also have the minimum values about the asphalt layer and the aggregate base layer. That will be the granular base layer. So usually you will have, for example, for the same parking lot with 200 to 50 to 500 stored trucks, and with the fair quality of the pavement, you will have the asphalt layer around the minimum value around 75 millimeters for the granular base with the minimum value of 230 millimeters. So this would be the some recommendations from the AI method for the specific pavement, the parking lot and the truck loading unloading area. And now let's go to see one example to see how we're going to use the AI method to complete the design of the pavement. So first of all, assuming that we are provided with the following traffic conditions and the soil characteristics, we want to design the flexible pavement for a two-lane highway. The initial average annual daily traffic is set as 2,000. And we set the annual traffic growth rate as 4%. The design period is 20 years. We also provide the CBR test data. And we say that there will be some possible freeze thaw effect. So which means that the MAAT is set as 15.5 degree. And now we want to find out the thickness of the pavement. The asphalt are the flexible pavements. At first, we want to do some analysis about the ESAL, and there will be some information provided, more information provided for you to analyze the traffic conditions. We say that for the traffic for the class of the traffic, we have 1, 2, 3, 4, 5, and 6. We have 6 different groups of the truck, including the single unit truck and multiple unit truck. And the second column shows the distribution, or shows the percentage of each group. For the 2A, 2-axle, with the load of 4 tons, then the with 4 tiles, the number is 49. For the 2-axle with 6 tiles, the number is 11. That will be 11% of them would be the 2-axle 6 tiles, and you can get the percentage of the other groups. And we know the number of the we can then calculate the number of the trucks, for every year. Say that every day the value is 49, and then at every year that will be 49 times 365. So that's how many trucks in the group 1. You can also find out values for the other groups. And the next thing is about the growth factor. We know the annual growth rate is 4%, and the number of the design period is 20 years. So with that, you can calculate the growth factor. The growth factor, which will be 29.79 for all the groups. I will not go through the details about the calculation. You can go back to check what the how to get the growth factor. And then for the design period, in the 5th column, you can find out the number of the vehicles in the design period for each group. So that will be the number of the the number of the vehicles, the number of the trucks that you observe in each group every year, times the growth factor. So this will be the give you the value for the lifetime number of the trucks in each group. And we also have the truck factors for each group. For the group 1 is 0.01, group 2 is 0.2, and so on. And then the ESAL for each group will be the truck factor times the lifetime number of the trucks. So with that, you can find out the ESAL for each group. And if you summarize them, you will get the total number of the groups. The total number of the ESAL for all the groups. So that's actually based on the 100 vehicles. And so this is the ESAL. And the next thing we want to find out is the MR values for the subgrade. So we will actually conduct the 8 experiment to test the MR values, and this is what we find from the field. To find out the distribution of the MR values, what do you do? That first you need to sort these values, all these observed values from high to low, and then set the values from the first one to the last one. So you have 8 values, so their values are estimated from 1, 2, 3, 4, 5 for each observation in the field. And the next thing is calculating the percentage. So the percentage is calculated directly as the value divided by the total number of the observations. So which will give you the first one as 1/8, second one is 2/8, and so on. The last one is 8/8. So that will be 100%. If this is about the case with the direct measurement of the resilient modulus, if you measured the CBR, you can use the equation MR equal to 10.342 times CBR to get the MR values, and then follow the same procedure to find out the distribution. With that, you can then draw all those pink lines, the pink points in this figure to show the distribution. For the value of 42.8, the percentage is 100. For 93.2, the percentage is 12.5. So that's what you observed in this graph, and then you're going to find out the line to fit to all these points. That's the distribution. That will be the distribution of the MR values for the subgrade soil. With that, you can then determine what's the percentage of the what's the percentile of the soil MR values we should select. So at first we can then go to check the all the values we have obtained previously. So we estimate the ESAL as 431,455 for the design period. This one's in the range of 10,000 and 10,000 to a million. So we decided that we're going to choose the 75 percentile. You can check the table I showed previously. And this one is applied for the percentile is applied for you to find out the resilient modulus. It will give you the value of 60 megapascal. From this figure, for the 75 percentile, that's 60 megapascal. And then we can go to check the MAAT. The mean annual average temperature, air temperature is between 7 and 24 degree. So this which would be 15.5 degree. And with this information, we can go to check the figures to find out the thickness of the pavement. It could be in full depth asphalt pavement. It could be the deep strength asphalt pavement. For the full depth, we can find out the value as 185 millimeters. So let me show you how to get it. So we have the ESAL. The ESAL is around so let me get an accurate value. It's 431, 455. So which will be some point here, and for the MR values, we get the value as 60 megapascal. So we will find out the point, the value in the vertical axis, and then to get the to find out the point determined by these two values. This red dot is the point that we can obtain for the thickness with respect to the full depth asphalt pavement. And remember that when you select the chart, you need to choose the one with the MA value around 15.5 degree. So by using the linear interpolation between these two lines, you get the thickness around 185 millimeters. So this is for the full depth pavement. And if we are considering a different pavement structure, the deep strength, say that we're going to consider deep strength with the granular base of 150 millimeters. Here we only have the possible freeze frost effect. It's not necessary for us to choose 300 millimeter granular base layer, but you can do that. You can choose it. It depends on your preferences. And again, we have the ESA around 4,300,000 for the MR value around 60 megapascal. With that, you will have the intersection, the point determined by these two values. That will give you the value around 100. It actually falls in the line of 150. So we get the minimum thickness of the asphalt layer for the deep strength as for the pavement around 150 millimeters. So that's the that's for the deep strength pavement. And with that, I think I have finished all the topics about the flexible, the AI methods, and we still have 5 minutes left. So I want to reserve this time for you to for the questions that you have, and also give you another assignment, or not assignment, another quick practice. So if I give you if I ask you to go to check the case with a 300 millimeter granular base, what's the thickness? What's the thickness of this design from the AI method? Can anyone give me a value about it? So you need to go back to check the chart for the MAT of 15.5 degree, and for the deep strength chart with 300 millimeter thickness. Can anyone quickly provide me with me about the value? Any ideas about it? Okay, I can probably go back to the figure for the specific condition with the MAT around 15.5 degree, the thickness of 300 millimeters. So this is the figure you're going to use. And we also know that the ESAR is around 4,300,000. So that will be some point here. And the resilient modulus is 60 megapascal. So by choosing these two lines, these 2 points, you're going to determine the point in this chart, and that will give you the value around given the point here, which is between 100 and 155 millimeters, and it's pretty close to 155 kilometers. So you can find out the thickness could be around 100 and 120, say that 123 millimeters, something like that. You can get more accuracy if we are using the actual scale. So that's how you're gonna get the thickness of the flexible for the flexible pavement with the AI method. With that, I think I will finish all the contents today, and also I designed the in-class questions for the first in-class questions. It will be published on Avenue to Learn, and as I don't want you to well, we have a very tight schedule, so I would ask you to just work on the in-class questions after the class. I will make it live for an hour after the lecture today, and you can work on that and just submit your answers there. Okay. I guess that's all today. Do you have any questions, any concerns that you want to add? Okay. If you don't have any questions, I guess that will be all today, and you can work on the you can then work on the questions on Avenue to Learn, and just feel free to submit your questions, and I will go through the solutions in the next lecture. Okay, I think that's all today. Thank you very much for your attendance. If you don't have any questions, I will see you tomorrow to continue the topic about the Ashton methods. Okay, that's good. Thank you very much, and I will see you tomorrow.